All right, guys, today we're going to be finding the area of a trapezoid using this formula that I'm highlighting in yellow over on the right. So the formula is half the height, 1/2 times the height, times B1 plus B2. B1 and B2 refer to the top base and the bottom base of this trapezoid, so the kind of ceiling and the floor, whereas the height refers to the distance between them right from the bottom to the top or from the top to the bottom of the trapezoid. So let's try this formula out over on the left side, where we're going to be doing 1/2 times the height, which is 7, times B1 plus B2, which in this case is going to be 10 plus 24. Now I think the easiest thing to do here is going to be multiply this half by 10 plus 24, which is 34. So half times that 34 is going to give us 17. We then have to multiply that by 7. So 10 times 7 is going to be 70. 7 times 7 is 49. So that's 119 as our final answer here. Next up, we're going to do area of rhombi and then area of kites. All right, guys. So next up, we're going to talk about the area of a rhombus. And the area of a rhombus and the area of a kite actually both have the same area formula, which I'm going to highlight again in yellow over here on the right side. So this area formula now is area equals 1/2 D1 times D2. What are D1 and D2, might you ask? Well, D1 and D2 are the distances across through the center of the rhombus. So you guys will notice D1 goes through this way, and D2 actually crosses it perpendicularly like that. That's in the rhombus. So let's look over here at this rhombus that we have on the left side, and we're going to find the area. Now, the thing that will help us out is defining D1 and D2. So let's actually define D1 as this upwards diagonal. So this is going to be composed of 8 and 8. So D1 is going to equal 8 plus 8, which you guys can probably guess is 16. D2, on the other hand, we're going to say runs across the rhombus. By the way, it really doesn't matter which one we call D1 and which one we call D2, since we're multiplying them together. But D2 in this case is going to be that 15 plus 15, which of course is 30. So now we got to roll out our area formula. So area equals 1/2 times, we'll plug in our two diagonals. So we got 16 and we've got 30. And if we multiply those together, well, 1/2 times 16 gives us 8 times 30, and 8 times 30 is 240. So our area for this rhombus is going to be 240. Next up, we're going to look at the area of a kite, which conveniently uses the same exact area formula. Okay, guys, next up, we're going to look at the area of a kite, and I'm going to highlight this, but you'll notice that the area formula is actually exactly the same as the one we used for a rhombus. That's A equals 1/2 times D1, which is the first diagonal, times D2, which is the second diagonal. So here we've got a kite, and I'm going to call D1 this vertical diagonal that runs from top to bottom. So we'll say D1 equals 3 plus 3, which is 6. Now for D2, we're going to say this runs the other way through this kite. I'm going to remind you guys that it doesn't matter which diagonal we call D1 and which diagonal we call D2, because we're multiplying them together. So 3 times 4 would be the same as 4 times 3. The order really doesn't matter. So for D2, we're going to say this is 4 plus 9 equals 13. Oh, and I should add there are units in this problem. We have actually 6 meters and 13 meters. So let's go into our area formula. Area here is 1/2 times 6 times 13, which does mean that we're multiplying 1/2 times 6, and that's going to give us 3 times 13. 3 times 13, of course, is going to give us 39. And we need to think about our units. We've actually been multiplying meters by meters, so that should give us meters squared. So our final answer here will be 39 meters squared. Thanks for watching this. The next lesson up is going to be area of regular polygons, which is a slightly more difficult formula, but we'll get there next time.